Yes, in the last class, we are talking about the mean and standard deviation, calculation of mean and standard deviation of group data. There are three methods, three formulas we have applied. One is a traditional method, just we use what sigma fx, that formula. And this one, mean equal sigma fx over sigma f. Here x mean the middle value and f is the frequency. That is one method. And second method, we use assumed method, assumed mean, right? Assumed mean plus sigma f fd over sigma f, right? So here the d represents the deviation. X minus d means x minus assumed mean, right? And third method, we use mean equal assumed mean plus sigma fu over sigma f into c, class width. So this is one method, right? So there are three methods. The same way, we use x minus x bar square over n. So this means sigma f. This is the main formula. Likewise, we applied the d, right? D and u. So we discussed three ways of calculating mean and standard deviation. Next, we will discuss how do we calculate the median. Median, you know that this is the central value, the position, central position. Mean is an average, but the median is a positional value. When we use this kind of measures, mostly we use the data same skewness. When sometimes the average say lies, right? Average may give inappropriate conclusion, interpretation, so that when average say lie, data skewed. The data may have some kind of outliers, right? So that times the taking average is not appropriate. Correcting for skewness by finding exact middle value. So what we do to calculate the median, as we did for ungrouped data, the median is split the population exactly in the half, right? Half. So if there are 20 data sets, here 10 and there 10, right? The middle value could be the middle value will be the median, right? In a group data, we find median class, but here in the group data, we have classes. So it is normally we take middle value x, but here we are not taking middle value. We try to find exact value, almost exact value of the value, median, right? Exact median, and then interpolate to find out the exact point within the bucket. So first we locate the median class. Within that median class, we have to find what is the exact value. For example, so this is a data set considering the age distribution of workers. It's given. You see the age, x is age in years, which are given in the class. And here there are 160 employees. 160, the median class will be 160 divided by 2. Then we will find 80th observation. 80th observation. How do we find 80th observation? Here, right, up to 498. Yeah, this 96. No, the 80th observation will fall in this class, because the cumulative frequency. This is top 10. Top 10 means below 24 years. 10, 10 and below 29.5, 26, below 34, 48. This is cumulative frequency, right? What is the total of this one? Cumulative frequency. 10 plus 16, 26, 26, 26 plus 22, 48, 48 in plus 48, 96, 96 plus 36. Likewise, we take cumulative frequency. All right. And here the 80th observation falls in this group, right? In this group. So this is the median class. Median class. Now we have located the median class, right? But we want to know what is the exact age. What is the exact age here in this class? Here 35. 35, 35, 36, 36, 36. Likewise, there are 48. There are 48. We don't know what is, whether it's 35 or 36 or 37 or 38 or 39. We don't know. But we have to find. So that's a formula. That's a way to calculate this. Here, this is the formula to calculate the median, right? To calculate the median, first we have to identify the median class. In this example, we can identify the median class. Median class. How can identify? Here there are 160 divided by 2. We know that the median is the middle term. So the 80, right? 80th, the 80th employee will be the median employee. So the 80th employee falls in this class as here up to 48, here up to 98, here up to 132. So based on our logical reasoning, we can identify this is the median class. Here L mean lower boundary, right? What's the lower boundary? It's 34.5. Lower boundary is the 34.5, and the N is number of observation. In this case, number of observation 160 and divided by 2. Divided by 2. That's mean normal 2. And here sigma f1 sigma f1 means cumulative frequency. Cumulative frequency before the class. This is very important. Before the class. So this is the median. This is the median class, and we have to take this value. Right? This is the median class, but we have to take this value cumulative frequency before the class. This is the cumulative frequency before the class, and then it should be divided by frequency of the median class. This is the frequency median class, and C, we know that the gap is 5. Now we apply this. We apply here total number of workers 160. The target rank, the position, right? N minus 2, N divided by 2 is 80th worker. We have to find what is the age of 80th worker. The target class 35 to 39. So its frequency is 48. And previous cumulative frequency also 48. Then we apply, we apply 34.5. This is the lower value, lower boundary of the median class. And this is 160 divided by 2. And this is cumulative frequency of median class, before median class. And this is frequency of the median class. This is class width. So that we will get 37.8 years old. So based on the calculation, we can identify that, right? We can identify the median class. The median age is 37.5. Clear? Any questions here? Any questions? Right. We move forward. The next point. Next point is the mod, calculation of mod. So mod, we know that this is the high number of observation. A particular value occurs most to the most. The popular value, identifying the mod. So when we visualize the data in the histogram, it's look like this, right? It look like this, and this is frequency. This y-axis shows the frequency, and x shows the class. So which class give us the most popular? So the highest, right? The highest frequency number is a mod. So in this example, this is the mod class. This is the mod class. This is a mod class. But in the above, right, we find the exact median, not the class. Exact median. First we identify the median class, then we identify the median. Likewise, we also need to identify the mod. So when we look at the picture, we can see the mod class, not the mod. To identify the mod, there's a technique. That's a technique. Here, actually, this graph, the slide is it's wrong. The way of calculating is this. So there are 2 points, right? There are this is A and B, right? Of the mod class. There are 2 edges, and here one edge. This point, and this point. The next, right? So what we do is we have to connect this point, these 2 points, right? And we have to connect these 2 points. Where it's cross it here. This is the point they cross, and we have to bring this. That could be the mod. This value will be the mod. For example, this is approximate, no? Right? And the data, right? For this data set, we have to identify the mod. Identify the mod. So the mod class. What's the mod class? Which class can be considered as a mod class? Which class will be the mod class? So this is highest number of frequency, 48. This is the mod class. So the mod exact mod falls within this range. We'll see what is it. So we can display the data about data like this. So this one is the mod class, highest frequency. As I told you earlier, we can take the highest value, top corners, and the edges with their next and previous class, the point. Yeah, this point and this point. And we connect these. We connect these points. And then this point, say this point is a P, intersection point is P, and bring that point here. So this could be when you use the graph sheet, you can identify the exact value of the exact mod. So this is a graphical method. And another method we can use formula. So it's not possible to draw the histogram. We have to looking for the papers, the graph sheets. So the formula we can apply the formula, calculating the peak trend. The mod mean the peak. The mod formula uses differences between the peak at the neighbors. Here, in this example, we identified this is the This is the mode class. Mode class. And we have to identify the differences. We identify the differences between previous and the next class. Previous class and the next class. Here, the differences. This is delta 1. The difference between frequency of mode class and the before class. That's delta 1. And the difference between mode class and the next class median. That is delta 2. Right? Delta 2, the differences. Here we apply. So this is a formula. Mod equal lower class. So lower class boundary. Right? Lower class. So lower boundary of the model class. Sorry. Right? Lower boundary of the model class. And delta 1 divided by delta 1 plus delta 2 into class width. Lower boundary of the model class L, and delta 1 is given the frequency, right? Not cumulative frequency. So frequency differences with the preceding class, and delta 2 frequency differences with the succeeding class. The next class C is the interval of the width. Right here, this example. Here we use lower boundary is 34.5 at 34.5 plus, and the delta 1 is 48 minus 22. How much? 26. And delta 1 26 plus delta 2, the difference is 48 minus 32, it's 12, and the class width is 5. Class width is 5. And when we solve this, we can get the answer like this here. Mod equal 34.5. It's a lower boundary of the mode class. 26 is the delta 1. 26 is delta 1. 12 delta 2 and class width. So that when we solve this, we can identify 37.9 years. This is the mode. It means there are many employees whose age is approximately 38. Approximately 38. There are there are many employees whose age is 38. And when you see in the graph as well, you can get the same answer, 37.9. Right, this value. So this is the way of calculating the mod. And right, so we have identified mean, standard deviation, median, and mod. Now we move to find the fractional, the positional values, positions like Q1, Q1, Q2, Q3, right? And D1, D7, and D4, and P20, P70, P60, like that we can find, right? Positional values. So these are the quartiles, these are deciles, these are percentiles. I have explained in detail in the previous session when we discussed about these position values for ungrouped data. Strategic segmentation beyond the average. So the population, right? Assume this is the population, right? It's a minimum value, and this is maximum value, population, and there are number of observations, and we can divide whole data set into 4 equal parts. Then we call them as a quartiles. The quartiles, right? First quartile, second quartile, third quartile, and fourth quartile. Sometimes it's called lower quartile, and upper quartile. These are the middle terms. This represent 50%. 20, 25, 25, 50% of the data set belongs here. So when we calculate interquartile range, so this is Q1, this is Q3, right? This range. So interquartile range. Interquartile deviation, Q1 minus Q3 minus Q1 divided by 2. So we have discussed these things earlier. And deciles, right? The deciles, we divide the whole data set into 10 equal parts. 10 equal parts, and each cut point called D1, D2, like that. And if you want more precision, threshold, we can use percentile. So it divides the data set into 100 equal parts. 100 equal parts, right? 100 equal parts. How to calculate? The calculation logic is identical to the median, right? So how we calculate the median? Not mod, our median. Same formula we apply here, same logic. Simply changing the target. So if you want to calculate quartile, right, we will divide by 4. If you want to find out the decile, just we divide by 10. And if we want to identify the percentile, we want to divide the total number of observation by 100. But to find out the median, we divide total number of observation by 2. So half, no, half. But quartile mean 4 equal parts. So we have divided by 4. Deciles mean 10 equal parts. So we divide total number of observation by 10. Percentile mean it's 100 equal parts. So therefore we divide by 100. So this is the logic. No need to remember. This is a logic. Just rational thinking, not magic. Here data set is given, same data set as we use above. From the frequency to cumulative position, right? So this is a frequency is given, and cumulative frequency is given or not, we can calculate. Here, the key, right? The key to positions. The cumulative frequency is the key. This is the navigator where a particular position will locate. So this is very important. Cumulative frequency is very important for calculating any positions. This column act as an address system. It tells us, for example, that 48th worker, right? This is 48th worker is very last person in the 30 to 34th class, right? So this cumulative frequency ended here, 48. So the upper boundary of this class is 34, right? 34. So it's clear without any calculation, we can we can identify the 48th person age is 34, right? Then if I ask what is the age of 49th person? What is the age of 49th person? What's the age?
35, 39.
No, 39. So 35, only 35. Because we know that in this class there are 48 starting from 35 and ending with 39. So 49th person is age is 35, and 96th person's age is 39, right? Likewise. And tell me what is the age of 132nd person?
44.
44. Yes, 44. What is the age of 133?
45.
Very good. Now you have understand the logic behind this. What's the last person age? Last person age?
54.
Yes, 54. Yes, good. Right. 49th worker is the first person in the 35-39 group. So that is 35. Right. It's a logic. Now we we may use one formula for all scenarios. So whatever the quartile or percentile or percentile, we can use this formula. Even for median as well, we can use this formula. Right. We already find the median. The median is equal to 37.8. 37.8. By using this formula, 37.5. 37.8, no? Yes, 37.8. 37.8. Median is 37.8. Here, by using this formula, we find the median, because we know that median is Q2, right? Median is equal to Q2, right? We apply that one in the data set. This is a data set. Here, what is the median class? Median class. First, we have to find the location, right? First, we have to identify the location. Total number of observation is what? 160. There are 160 employees. And the median class, the median person will fall in so 80th person will be the middle person, median. And then also first we have to calculate the position. Here, what is the position? 80th, right? 80th person. If you want to apply Q2, right? Q mean 4, then K 2, right? Here, 160 divided by 4 into 2. This is the position. We locate the position. Q2. Q mean here. Q is here. Q mean 4. And this is K. K is here. And number of observation 160. Then it's equal to 8. So 80th observation. Right? When we look at here, right? When you look at here, 80th person falls in which class? Right? 80th person will fall in on which class?
35, 39.
This is called what? This is the median class, the position, the target class. Now, according to the formula, the lower boundary of this class 30. What's the lower boundary of that class? Lower class
34.5.
34.5, right? 34.5, right? Plus, and here the position. What's the position? Position is simple, right? Here, position means we have to find a quartile for 4 and number of observations 160 and into 2. Or you can write 160. So this is a formula, right? The formula is this. To calculate the position, the formula is n, right? N into position. If you want to find quartile, 4, right? 4, and we find the second position, and simply K, Q, K, right? N, K, Q for the quartile. So for second quartile, we have to find, so K equal to Q equal 4 and N equal 160. So this is here 80. The position is 80, 80th person. So that 80 minus cumulative frequency of the preceding class, FCF. CF means cumulative frequency of previous class. Here, tell me what is the previous class? QF, CF is what? Yeah. Cumulative frequency of previous class is 48. This is our model class. And cumulative frequency of previous class is 48. And divided by frequency of that class. Frequency of the class. C mean frequency of the Tucker class. What is the frequency of the Tucker class? What's the frequency?
96.
48. And multiply by the C. Class width. Class width is 5. Just solve this one quickly. 34.5 plus then 232 over 48 into 5. Solve it quickly. What do you get? What do you get? It's equal to
37.8.
37.8. Same answer what you get earlier. Okay, 37.8. Yeah, 37.8. Right. In this way, in the same logic, we identify the Q1. Find Q1. How to calculate Q1? Right. First, we have to find the position. Step number 1, calculate the position. Position here, Q1, no, Q mean 4. This is K. K1. This is K. Right. This is K. Here, position for 1 into 160 number of observation. So therefore 40th observation, right? Location is 40th observation. Then we apply the formula, right? First we have to identify the model class. So where the 40th observation falls here? Where? In which class 40th observation falls? On which class? 40th observation. In which class?
30, 34.
Yes, 30 to 34, because here, not here, because after 26, this is 48. So 48% is here in this class. So this is the model class. Model class. What's the lower boundary of the model class?
29.5.
Yes, 29.5. Very good. 29.5 plus then cumulative frequency of the model class, previous class. Cumulative frequency of the previous class. What is that?
26.
26. 26. Right, 26. Here position 40 and 26. And the frequency of the model class,
22.
30, not 32. Frequency 22.
48.
Yeah, 22, not 28. Not cumulative frequency, right? Frequency F. Then class width. Class width. What's the class width?
5.
Yes, 5. Then quickly solve this. 29.5 plus 4, 22 into 5. Quickly solve this. That's the answer. Yes, what's the answer? It's equal 30.9, right? Correct? Correct? Or different answer? Right. What does it mean? 30.9 means when we divide the whole 160 employees, 60 employees, whole 160 employees, we can divide them into 4 groups. Right, the middle, right, middle, here 37.8. Middle, this is Q2. This means there are 80 employees or 50% employees below 37.8 and another 50% of the employees above 37.8 years old. That's the meaning of Q2. And here Q1, this is the cut point. This is 30.9. 30.9. It's mean 25% of the employees, 25% of the employees, right, below 25% employees, age below 30.9. And the next 25% of employees, age is 30.9 to 37.8. Next 25% employees mean next 40 employees age is 30.9 to 37.8. And the first youngest, first 25% or first 40 employees age is below 30.9, right? This is the meaning, right? Likewise, we can calculate Q3, the third cut point. Very easy, right? How to calculate? 4 or 3, right? This is Q, this is K, and number of observation 160. So that we can identify the position. So therefore 120th employee, 120th employee. Then from this data set, what is the model class? What's the model class? What's the model class? 120th.
44.
Yes, very good. This is the model class. The lower boundary, what is the lower boundary? 39.5 and the frequency is 36 and cumulative frequency 96 and class width is 5. Right? So we directly apply this formula. Right? Here we know that 39.5 is the lower boundary of the model class plus, and the position is 120 and the cumulative frequency is 96 and frequency, right? Frequency equal to 36 and the class width of the model class is 5. Then calculate the value quickly. What's the answer?
42.8.
44.8.
42.8.
Oh, sorry, 42.8. Okay, 42.8. Yes, here, same answer, right? 42.8. Here, what's the interpretation? 75% of the workers are below age 42.8. 42.8. So this is here up 25, 25, right? So 75% of the employees age below 42.8. What are the top 25 percentage? Right, top 25 percentage. The top 25 employees. This means 160. No, there are 40 employees. The this most senior employees group. Top 25% of the employees' ages are above 42.8. And the middle age groups here, middle age, these are the too young, this group too young, these are older, and this is the middle age. This is middle age. The middle age between 30.9 to 48.8. 50% of the employees falls on this category. Right, middle age, not young, not too young, not too old. Right, so this is what the data set give us. Likewise, we may identify D4, decile 4. Decile 4. So D mean 10, K 4. So first we have to identify the position. Here, 160 number of employees into 10 by 4. Then we can cut these zeros and location 24, 64. Right? We have to find the 64th employee, D4. Right? D4, 64th employee. Can you calculate quickly? So accordingly, what is the model class? Model class for 64th employee? Yeah. What's the model class? 64th employees falls on which class? Sixty-fourth employee?
35, 39.
Yes, very good. Here in this class. So lower boundary is 35, 4.5. And frequency is 48. And cumulative frequency 48. And yes, class with 5. Let's apply. Let us apply. Lower boundary 34.5 plus, and the position 64, right? 64 minus, and cumulative frequency is 48, and the frequency is 48, and class with 5. Then how much? 34.5 plus 2, sorry, 6, 16. We'll calculate quickly.
Final answer is 51.1.
And what is that?
51.1. Final answer.
Yes, what is that?
Sir, 51. 51.1.
51 can't be, no. 51. It should be fall in this category. It should fall in this category.
36.1.
36.1. Okay, 36.1. Right. Is it correct answer?
Yes, sir.
Okay, okay. So quickly calculate D7. Quickly calculate it. D7. Okay, now the answer 41.7. Right. So right. So now you understood how to calculate Q and D. Let us work on how to calculate percentile. Percentile, say for example, P30. Right? P30. In this instance, P means percentile. So therefore, that is 100. 100 equal parts. And K is 30th observation. Right? Not 30th, sorry. 30th. Percentile 30. So it's mean out of 100. 30 into 160. So therefore, this and we got this. How much?
48.
48. Yes, 48. So we need 48%. What's the age of 48 percentile? 48. Without doing calculation, we can say. Without doing
30,
calculation.
34.
No. 34. Exactly 34. Exactly 34. Right? Let us work. Let us work. Let us work.
39.
No. 48. The answer is 34. Would be. Right? Let us work. 48th position, no? Right. So 48th position looks like here in this category. So lower boundary is 29.5 plus, and the location is 48 minus previous cumulative frequency is what? 26. 26 divided by 22. 1 minute. Right. Here, frequency of the class, model class is 22. Right. And the class width is 5. Right. When we solve this, 29.5 plus here 2 and 2 and 2, right, and into 5. This is 5. So 29.5 plus 5 equal 35. Yes, it's 4.5, no, 0.5 and 4. Yes, 34.5. You see here the lower bound, right? The upper bound, right? So without doing calculation, we can find it directly here. What is this? 48th position. So as we discussed earlier, the 48th, the last person in the group. Right? Clear? There is a logic. It's a logic. Here D, right? D3. Also D3 also same, no? D3. We didn't calculate, I think. D3, did we calculate? We calculate D4. D3 equal P30. Right? You can see this. 48th item. Right? P66. Calculate P66. What's the value of P66? P66. Quickly calculate P66. Right, what is that? What is that? Answer?
40.8.
0.8. See, 40.8. Here. 40.8 or 40.9?
8.
Okay, let's see. P66 mean, so it's the location could be 105.9, 105.6 item. So approximately locate, right? We locate 106th item, right? Approximately the next. No, it's better to approximate to next hash level. So that 106th item will fall here. Cumulative frequency here, therefore 39.5. Okay, 39.5 lower boundary, and here 5.6 the position, and the cumulative frequency before 96 is here, and the frequency of the class 36, and the class width is 5. When you solve this, it's rounded to 1.4, and it's almost right, 40.9, 40.8. Okay, right? So yeah, you're getting correct answer, right? And so this is the logic behind this. Here we have calculated all these things. Here this is Q1. Q1 is 30.9, and Q2, Q2 is the median, 37.8 or something, and the Q3 here 42.8, and the D30, everything we have calculated. So first 25%, right? Q1 junior talent, junior employees, and the top 25%, Q3, right? Q3 senior, right? Top 25% age, and the middle age. This is the middle group. Workforce density, right here. So these are the 50% of the employees are here in between this age to this age, right? So this is the behind. This is the thing. This is the logic. Which is the reason behind. This is the insights behind the calculation. And here, same thing here, right? Q1, Q2, Q3, as I told you earlier. And advanced application here, this is monthly income. That second example, a case study. A monthly income distribution of 600 people. There are n equal 600 in a city A, are shown in the table below. So the monthly income here, they give us the class boundary in different way. 4,000, right? 4,000 income, right? This is a monthly income. 4,000 rupees. 4,000 rupees and less than 6,000. Actually, it means the lower boundary is 4,000, right? 4,000 to 5,999. Here 6, and here is 6,000, 6,000, and 6,000 to 7,999. This means it also includes 5,099.9 as well, 0.999 as well, right? So here you don't want to take the middle point. So it's mean the boundary. So normally what we take boundary, for example, 4,002, sorry, 4,002, 6, sorry, 5, no, 5, 5, and 6 to 8, and 9 to 12, like that, no? So in those instances, we take this value and this value, right? 5 plus 6 and divided by 2, and we get 5.5. No, this is the way we normally do. But here, less than 6,000 mean even this class may get the value up to 6,000 without 6. If it is 6,000, it's will come here, but 5,999, right? Any value falls here, right? Not 0.5 rule here. Right? It's clear? Clear? Right. So this is very important here. And it's given there are 600 employees. 600 employees. The policy, they want to make a policy scenario. The top 10%, top 10% of the earners in the city A must pay city tax. So top 10 mean is what? Top 10 mean, top 10% mean 90%, right? 90% mean 90th percent. Any citizen whose income is above 90% of the total city salary, right? No, city's population has to pay tax. So top 10%. So it's equal to what? D9 or P90. So we have to find the cut point. We have to find the cut point of 90th percentile. This is the cut point. This is the income range. Income range. There are 600 people, and we have to find out the 90th percentile. And any employee, any person whose income is this above this cut point has to pay city tax. So we have to find how to find how. Here this is the data set. So there are 600 employees, 600 citizens, and we have to find 9th decile or 90th percentile. So here it's given in percentile, so we can find percentile, divide by 100 and 90th. So we can cut these two and 540. So we have to find 548th people. 548 people. Can you tell me by looking at this? So by looking at this table, we can't see. So first we have to find the cumulative frequency. Cumulative frequency. So this is 15. 15 plus 38. What is that? 53. Likewise, we have to get the cumulative frequency. And it's end up with here 600. And 548th most probably, and false here, no? Yes, false here. And this is could be 590. Right, so most probably it falls in this category. In this category, so lower boundary is 14,000. Lower boundary is 14,000, and the cumulative frequency of this class we have to find, and frequency of the target class, model class here, and the class width. What's the class width? It's 2000. Class width is a 2000, right? Class width will be 2000. So this class 2014, 16 minus 14, 2000. Right? When we apply this, yeah, 40, right? Yes, yeah, 14 exactly. For lower boundary is 40,000, 14,000, and we know 540. This is cumulative frequency. This is position, location, right? Then this is 497. That is here 497, right? This cumulative frequency 497, and frequency of here 68 and 2000, right? Then it's equal 15,265. It's mean any citizen whose income is above 15,265 rupees has to pay tax, city tax, right? The tax threshold, income level above 15,265 trigger the tax, right? So this is the summary sheet. The median, mean, median, mode, standard deviation, percentile. And so this is what we studied. First, we studied the midpoint, mean, median, right? Mean, median, and standard deviation, and then we studied variance and standard deviation, and range, interquartile range, mean deviation, right? We have discussed on the variance and the segment target actions. So we can do some policy decisions. And here this is an exercise. Here the data is given to you. Distance traveled by 60 sales representative of the firm during the week are shown in the following distribution table. So here the question is calculate mean, median, standard deviation, coefficient of variance plus calculate Q1, Q2, Q3 and D5 and P5 and calculate D3 and D6 and P75 and P25 and P15 and P90. Right, so this is the exercise. Please take a screenshot and calculate.